Hearing about how massive wind turbines are built is one thing, but seeing it is another. Last year, I got to visit the Beckevar wind farm in Saskatchewan, Canada, months ahead of its completion in November of 2024. As I explored the project construction site, I witnessed firsthand the vast amount of effort it takes to get 36 turbines up and running. I got a taste of a little bit of everything: the nitty-gritty of permitting and safety protocols, the complex transportation logistics, and of course, the thrills of crane operation. So what did I learn from my turbine travels, and what can we learn from Beckevar? And just how do they handle the insane logistics of building such a massive project? I'm Matt Ferrell. Welcome to Undecided. This video is brought to you by Surfshark. Now, we've done a lot of talking about wind turbines on this channel. They're large machines in a large industry working towards an even larger purpose. But at the end of the day, height comparison charts and explanations of the square cube law are an abstraction. No amount of stock footage can truly capture just how massive wind turbines are, and the same for their operations and deployment. It's something that you have to see on the ground to kind of understand. And that's what I bring you today, a view of a wind farm in progress from my own perspective. So let's go over exactly what we're working with, starting with the cast of characters. The Beckevar wind farm is itself jointly owned by Green Investments, an investment platform for utility-scale renewable energy projects, and the Cowessess First Nation of Southern Saskatchewan, Canada. The Canada division of RES, a global renewable energy company, acted as a general contractor and oversaw the organization of the entire project. Canadian company Energy Wind and Renewables installed the turbines, which were supplied by the Europe-based manufacturer Nordex. And finally, Rising Edge Group, which operates in North America and the Caribbean, had its Canada team cover the transmission tasks, including drilling, cables, and the power station. It definitely took a village. As for the stars of the show, we have 36 of Nordex's N155 turbines. We're talking about several hundred tons of weight, 184 meters or over 603 feet of height, and a power output of up to 200 megawatts. That's about enough to cover the electricity usage of roughly 100,000 homes. Here's project manager Chad Serafin breaking down the turbine dimensions.
So the hub center will be 108 meters in the air.
Oh, wow.
Yeah.
Okay.
And then your rotor diameter is 155 meters, right? So from tip to tip would be 155 if you're able to draw the circle perfectly around it.
With a project this big, where do you even begin? Well, I can't share the secret recipe for the wind farm in full, but I can give you a step-by-step breakdown of how the pros brought it all together. And to put the timeline into perspective, construction started in May of 2023, and the companies involved in its completion celebrated its grand opening in November of 2024. It all started with the base of operations. For this project, that meant building a batch plant yard and a laydown yard. These are centralized logistics hubs where workers and parts go. As I said myself,
Wow. A lot of parts.
Once RES brought all the workers to the yard, it was time to modify the nearby infrastructure to make their lives a bit easier. That meant intersections to accommodate turbine deliveries and roads to access each turbine location.
These blades for this site all came on a truck. So they all came from basically Port of Washington, down in Washington State.
Right.
They trucked them across the upper north. West, right, in through Canada, and then they get driven up here. And then once they hit site, because if you notice, a lot of the roads are 90 degrees.
Yeah.
So we've created sweeps and jug handles for that blade to maneuver around the corners.
Once workers excavated the foundations of each turbine, the next order of business was the mat. No, not me, the mud mat. Along with the anchor bolt cage and the rebar mat, these keep the concrete in the base of the turbine upright. Think of them like the boards and dowels that professional bakers use to keep the tiered cakes from turning into edible landslide dioramas. After these excavations were backfilled, the next layer in the wind farm cake is what's called a crane pad. This is a specific compacted aggregate on top that can handle the weight of the cranes that are used to safely construct the turbines. Without it, the cranes might sink into the ground or tip over. Here's where it starts to get really delicate. You can say it's when the construction kicks into high gear. But before getting into that high wire act, there's something else that I got a lot of use out of during my trip to the build site. During my flights there and in my hotel room, I had to jump on a lot of public Wi-Fi to get work done. I used today's sponsor, Surfshark, to secure my internet connection, but I also made it look like I was back in the US to stream some TV shows at night in the hotel. I've been using Surfshark for what feels like forever, and I get so much use out of it. Surfshark is a fast, easy-to-use VPN full of incredible features that you can install on an unlimited number of devices with one account. But that's not all. Even shopping services will sometimes gate prices based on your location, so you can change your location to make sure that you're getting the best deal. They also have add-ons to their VPN service to unlock things like Surfshark Alert, which will let you know if your email or personal details like passwords have been leaked in online data breaches. Right now, they're running a special deal. Go to surfshark.com/undecided to get up to 4 additional months for free. Surfshark offers a 30-day money-back guarantee, so there's no risk to try it out for yourself. I've been using Surfshark for years and I love it. Don't miss out on this great deal. The link's in the description below. Thanks to Surfshark and to all of you for supporting the channel. So back to the construction kicking into high gear. And high gears, they are. Again, these turbines stand at an imposing 184 meters or over 603 feet. That's more than double the height of the Taj Mahal. Just look at the size of the equipment required to pull this off. So as you can imagine, raising these towers was an incredible act of precision, one that was repeated 36 times. First, drivers delivered turbine parts to the location. Workers began to raise the individual tower sections one by one. Each section stacked on top of each other kind of looks like a giant tin can, which is exactly what the team called them.
This is the table. So the table will get flipped over and it'll go in the center, right up there.
Okay.
And then what will happen is plates and the brackets will get installed on top of the table. And then the switch gear, which is behind that hoarding right there, it'll get placed on top of the table. And then when base mid makes it over here, that first can with the door on the side of it, it'll come down on top and the table and the switch gear will already be inside. So they've got 5 cans there.
Okay.
So they would have came around first with a base mid crane of 1500, and that would have stacked out the first 3 cans. So then this guy would come around and he would have 2 more cans to place on top of the first 3,
Okay.
because he's got the height.
Now, according to Chad, it took about 8 hours to get to this stage. And once the workers raised the cans, it's the nacelle's turn, which contains the turbine's gearbox. I can't say nacelle without thinking of Star Trek. That's me. Anyway, then the drivetrain followed the nacelle. The drivetrain, made up of the gearbox and the generator, is what converts the blade's rotation into electrical energy.
He'll take the roof off of the nacelle, they'll prep the nacelle on the ground, and the nacelle will go up. And then we'll attach the nacelle to the first can. Once the nacelle's fully attached, the yaw's fully attached, then we'll fly the drivetrain in, place the drivetrain in. Once they have the drivetrain bolted down, right, they'll fly the roof back on to the nacelle, and then the hub will go on. So the hub will go on the front face of the nacelle, right? And the center of that hub is 108 meters.
Okay.
From there, they'll start flying the blades. So they'll rotate the hub and they'll fly a blade in, stick it in roughly around the 9 o'clock position, and they'll rotate it around fully. Then they'll stick another blade in at that 9 o'clock position, and they'll rotate it around fully, and they'll do it again for the 3rd time.
But let me tell you, this was all way easier said than done.
You make it sound way easier than I know it is. It's a very delicate operation.
It's a very delicate operation, right?
Andrew was describing to me, like, when you're sticking a blade in, there's a lot of bolts.
There is.
And they have to be perfectly aligned.
Correct. Yeah.
How difficult is that to get that?
It is quite difficult, but with experienced crane operators and an experienced top-out crew, installers up there, they make it look like butter. Honestly, they do. Like, they're just, that's what these guys are good at, right? They're 108 meters in the air, right? The height doesn't seem to bother them at all, right? They're just up there with their radios calling in the crane, letting the crane operator know where they're at and how close they actually are. And like, yeah, they do a really good job. You know, we always strive, like, you're professionals at your job, right? So be professionals, and it just comes naturally. And we see that a lot with these guys. You want to take a look? So that's the yaw. That's what spins the whole nacelle when it gets bolted down on top.
So that adjusts the direction that the turbine is facing.
Yeah.
Okay.
Into the wind. And then up here this is where the drivetrain would sit on.
Oh my God. The drivetrain is huge.
Yeah, it's over there. We'll go over there and take a look at it.
After that came the hub, and finally workers stabbing in the blades. I was actually lucky enough to have the incredible experience of walking around inside a hub myself, led around by Zach.
God.
And just an explanation. So these are your rams that turn each of these faces. And then you'll have all of your hydraulic hoses and everything that feed the ram.
Right.
Then they move in and out, which will rotate this.
Okay. Okay, so somebody's job is once those all come in, you have to attach bolts
Yeah.
all the way around.
Yeah, so your studs will come through. So there'll be a guy outside in the shrouds, and then you'll call it. You'll call the part up and in, and basically it's you and the crane operator. Once they come in and your face of the blade is against the face of the hub here,
Yeah.
you'll have guys in here that start throwing nuts on all the way around. And then they'll do a pre-torque. And then once it's pre-torqued and they have all that done, then we can de-rig the crane from it, and then the blade just hangs.
Okay.
And then usually we try to get all of them up as soon as possible. So we'll do our pre-torque, rotate around till the next one, because there's the certain position that you stab them at.
Right.
So we'll rotate around until the next face is in the stab position, and while they're rotating, we'll be rigging up to the next blade to send it. By the time they're around, we'll be pretty close, and then that one goes up, stab, spin again, and rinse and repeat, basically.
So to orient myself, this is the part that's attached to the nacelle,
Yeah. So
and
this-
that's facing forward. Okay.
Yeah, that would be your nose, and
Right.
then, so basically it'll come like this. And
Right.
Wow. Now that would all take about 18 hours under perfect conditions. But as Chad explained to me,
Mother Nature
Yeah.
sometimes chooses a different path for us.
we'll get to the whims of Mother Nature and how that affected the project later. Before we go over that though, let's talk about the business of the electrical connections themselves. After workers put together all the turbine pieces, how do they hook them up to the grid? Well, that's what kept another set of workers busy down in the trenches as they laid the cables that connect the turbines to the power station. While I didn't get to see this myself, the machine that the team uses sounds absolutely fascinating. In one step, it digs the trench, lays the cable, and then folds the earth back into place. As soon as that was done, local farmers could come back in and replant their crops. As environmental supervisor Cole Siddons told me,
that is part and parcel thanks to Rising Edge, the contractor that we used for that. They specialize in doing things like that. And from day one, they always had environmental at the forefront of what they were doing. And that was one thing that is a big selling point for them too, is not only can they get the line in the ground in a timely manner, they also reclaim, remediate behind them while they're doing it.
once the electrical lines are laid, workers connect them to the wind farm substations that the turbine's power can flow into the grid. Here's electrical manager Dwayne Leicht giving me a tour of the electricity's domain.
What am I looking at here?
This is what is commonly referred to as a substation.
Yeah.
Basically, it is designed to control and direct the flow of electricity. On this side is the high voltage side. So we see current transformers, we see voltage transformers, and we see surge arresters here.
What are those?
The devices on the left?
The two units that are right there.
Okay. Those are current transformers.
Okay.
So what those do is they'll take the amperage that's flowing through the line and reduce it by a known ratio, and then through secondary wiring it goes inside the building for both metering and protection.
Okay.
So like there's going to be, say, probably in the neighborhood potentially of up to 500 to 600 amps flowing through the line. So you don't want that in the building because of safety. So they drop it down to by a known ratio, so it's a safer value to be used in the building.
Okay.
And then any equipment in the building knows that ratio, so then it can mathematically step it up.
Okay.
So you get an assumed value.
So you're constantly stepping it up and stepping it down?
Yes, yeah.
Okay.
The devices on the right-hand side of us here, those are voltage transformers, or more technically, capacitive voltage transformers.
Okay.
They do the same thing with voltage as the current transformers are doing with amperage.
And what about over there? This is what are each one of those individual boxes?
Those gray boxes are all circuit breakers. There's 5 of them. So we have 8 circuits feeding from the turbines into the substation. there's 2 circuits going to one of each of the 4 breakers. The 5th breaker is for the capacitor bank, which helps filter the power.
This is going to be oversimplifying it, but it's kind of what's in your home circuit breaker system, just at a huge scale.
Exactly. That's much like the breaker panel in your house that trips if you plug in the toaster and the coffee maker at the same time.
Yeah.
That helps protect the equipment. So if there's a high current usage, like in the case, like say a short circuit. So if a cable faults underground and creates a high short circuit value, the breaker will trip off.
Right.
It'll automatically shut down to protect the system.
Right.
Because those you don't replace off the shelf from Amazon.
That said, there were plenty of obstacles and no shortage of wrenches that could be thrown into the turbine raising plans. For starters, safety first. I was very impressed by the pod meeting I sat in on, which is the team's daily stand-up. During the meeting, each group reported what they'd done, what they needed to get done, and any ongoing challenges. There was a storm coming in later that night, and the number of people bringing up safety and making sure to talk to your crews was really awesome to hear. I talked to the health and safety supervisor, Logan Trick, about that some more.
So everyone during those pod meetings has a chance to say something, which is fantastic. And it's nice that they start off with safety because it's a good reminder to everyone that safety takes precedence over everything else.
And during my time at Beckevar, multiple workers remarked that it was the windiest site that they had ever built on. Wind speeds above 11.2 meters per second or 25 miles per hour meant halting work until things died down. And while I was there, the wind speeds hit 12 meters per second at times, so even I got to see some of these work stoppages.
So from your perspective, what's the most challenging thing that you have to deal with?
Site conditions.
The weather.
The weather. The site conditions and the weather are a constant. You know, we spend lots of time on the pre-job working out the logistics of getting everything here. You know, we figure out what cranes we need, booking them for rental, getting all that moving along. It's just what Mother Nature throws at you, and then how you're dealing with it and how you're keeping the job on schedule.
Like this wind.
Yeah, that we're currently in right now. Which is a good thing because
that's what it's here for.
That's what it's here for. So yeah.
The powerful winds also meant that the towers would shake, and noises from even the slightest movements were kind of magnified inside those towers. For example, without retaining clips to hold them in place, the workers' fall protection system, or lifeline cables, would smack against the metal walls and create this really eerie droning.
Oh yeah, you can hear it.
That's the cable.
That's the lifeline cable.
Jeez.
Now you might be thinking, if it was this loud under construction, how do the turbines sound when they're actually in use? Well, Chad showed me that there were mitigations put in place to reduce the noise.
So what are the this little spikes here at the end?
So those are the serrations.
Yeah.
Helps with sound.
Okay.
Right? You can imagine a 77-meter blade spinning and the sound that it would have coming off of it.
Okay.
So it just helps reduce that sound.
Okay. To make them quieter for the surrounding community.
Exactly.
Okay.
Speaking of the surrounding community, how did this project impact the land of the people who live on it? When it comes to the environment, the project had a dedicated supervisor role through RES.
I am responsible for ensuring that the environment in this area is protected and is put back, when we finish this project, that it is not impacted in a substantial way that alters the way of life around here or alters habitats and wildlife in the area. Okay. So that goes all the way from preventing spills, ensuring that for prevention of erosion and sediment control, prevention of pollution, so controlling waste, controlling erosion and sediment, and ultimately controlling spill response and wildlife response.
To minimize disturbing the land, RES worked with local farmers to both preserve the area and to promote worker safety. Now, according to Cole, his role is actually not all that common in the industry, so RES actually does stand out for its environmental approach. And honestly, prior to meeting him, I didn't know these kind of jobs existed.
Well, I will say this to a lot of the viewers out there. If you ever go to any of these renewable energy projects and you go to the prime contractor, there's a very good chance they will not have a person like me there, a dedicated environmental supervisor. You will have a lot of people who juggle multiple roles or juggle multiple responsibilities, but a defined person will be rare to see. So Res definitely does take an extra step and an extra care in ensuring environmentalism and preventing things from happening, right?
Now that the project is complete, the power the turbines are generating, which is up to 200 megawatts at full capacity, is being sold to the Saskatchewan Power Corporation, or Sask Power. And in a press release announcing Begavar coming online, Chief Erica Bodana of Cowessess First Nation, which has joint ownership of the farm, had this to say. We're excited to be a part of this important initiative and to see it come to completion. As Indigenous people, we feel it's our duty to not only invest in clean energy, but to place ourselves front and center as leaders in clean energy. Jotun, wind in Cree, plays an important role in our cultural ways of being, and we firmly believe this mighty spirit has many more teachings and blessings to bestow upon us all. So what did I take away from my experience there? Well, I'd say the most consistent thought as I moved through the site was that I was amazed at just how much skill and care was required at every step of this process. From the tools needed for keeping farmland as intact as possible to the weeks needed for assembly of a transformer. I think Chad was onto something when he called the coordination of all these operations an orchestra. But what do you think? Are you as impressed as I was at the level of coordination and engineering that it takes to bring these giants together? Jump into the comments and let me know. And be sure to listen to my follow-up podcast, Still to be Determined, will keep this conversation going. And thanks as always to my patrons for your continued support. Keep your mind open, stay curious, and I'll see you in the next one.